Hello, and welcome to the Outlier Podcast, the podcast for everyone who is interested in building better homes. My name is Anthony, and I am the founder and lead designer of Outlier, and I'm passionate about creating beautiful and high-performing homes. I sit down regularly to chat with industry experts to help educate Australians about the potential of creating healthy, comfortable, and energy-efficient homes. Whether you are looking to build your forever home, renovate your existing house, or simply eager to learn more, tune in every month wherever you get your podcasts. We hope you join us on this journey. This is episode 19, and in this three-part episode, we chat with David Dimovski from David Belle Design. David provides an honest account of designing and building his own family home to Passiv house standard. We dive into the details of what makes this home different from a conventional constructed home, including the building fabric, assembly makeups, and how he used Passiv House Planning Package, or PHPP, and WUFI to assist the design and value management. We conclude with some of the low moments, the feel-good moments, and what the future of industry may hold.
Yeah. So we've touched on ventilation. We've spoken about the thermal envelope. I've got a pretty good grasp on your walls and your roof now. What's happening in the floor?
The slab in the PHPP originally, when I first had the idea, and I don't know why, but I think it happens to a lot of designers, you get tunnel vision and you're like, oh, I'm going to put 100 mil XPS and then I'm going to put 100 mil slab, and you just work with these neat numbers. But then that was when I was just learning about the PHPP. And I started mucking around with the numbers. And I'm like, oh, I can get away with 50 mil. Like that's fantastic. So that saves a lot of money there again. So under the floor, I've got, I'm trying to think back on the engineering now. But there's two slabs that are 100 mil thick, and then one's 130 double meshed. So underneath all of them, there's a continuous thermal break essentially of XPS foam. 50 millimeters, and there is also around the perimeter of all the slabs a Novamir block. For those of you that don't know what that is, it's basically just, if you think of a brick that's kind of wrapped in that white packaging foam that people use, the styrofoam, and that kind of acts as a thermal break from your concrete slab to your footing. It doesn't completely eliminate it, but when you do like an analysis on it, it gets you pretty far over the line.
And so you've now given a complete picture of one of the other principles of Passiv House, which is thermal bridge-free design. Yeah. So you've got your continuous line basically of insulation around your thermal envelope, which is your thermal envelope, which now is. Are there any thermal breaks that you've had in the home? Then how you've done with those? Thermal bridge, yes.
Yeah, I've got one thermal bridge in my garage, and the WUFI analysis. It kind of determined that it wasn't an issue. But essentially, the two beams supporting the upper floor where my master bedroom was in the garage, they were going to be like an LVL timber. It came in at like a 6 meter by 500 mil by, I think it was 85 mil. Huge glulam beam. Like we're talking like $3,000 each. Or $3,500 each, I think they were. And I was like, oh, God, that's pretty pricey. So went back to the drawing board, PHPP, opted for steel, changed them. And it's not as good as what the timber was. And obviously you've got that, when you think about a steel I-beam, now you've got that really dicky little profile to deal with in the letter I, opposed to like a nice rectangular beam that you can insulate around. Yeah. The analysis showed that it wasn't really going to cause too much of an issue. So again, saved a little bit of money there and did end up with one kind of, if you could call it a thermal bridge. Yeah, it is, but it's not really detrimental.
That's great to hear. And you're going to have to explain WUFI now.
Oh, yeah. So the analysis that I'm talking about is WUFI. It is a piece of software that you basically, what would you do? You'd put in to keep it super basic, you're comparing the effects of your building materials opposed to the outside and the indoor temperatures, and then seeing the results of that, what bleeds through or how much energy loss you get through. It can tell you cold points in corners and stuff like that. So
which to my understanding is what most people are using for, correct? Like any moisture issues that may occur now that you've
moisture
got a high thermal
right.
conducting material like steel, and what's going to happen when you have a high point of temperature differentiation, and is that going to cause moisture form or condensation form there?
Yeah, exactly.
So
right.
that's what so you've been able to mitigate risk by having that WUFI analysis done to go, no, it's all good. There's no moisture or condensation concern there.
Yeah, correct. And that happens throughout the PHPP process. So you'll essentially do a WUFI analysis for it depends on what your certifier asks for. So I'm using Luke from Detail Green. He's obviously done this probably the most in Australia. I think he's probably done he's done all of them.
Yeah, fair to say.
But so he's quite confident in a lot of build-ups, and if he sees something before, he's not going to ask for a, if he's seen it before and he knows it works, it's okay. But for stuff that he hasn't seen or stuff that we need to get clarification on, you just send a little detail over, you get a WUFI analysis done, get it back, and then that just tells you and make sure that when you go for your certification, it's all as built. Which the whole point of Passive House, again, it's to make sure that you're building the best building as possible, but you're also kind of checking it as you go along through blower door testing, WUFI analysis, stuff like that. So,
and as an owner builder, you've got to be fully accountable. So,
yeah, I'm accountable for it. Yeah, exactly right. Well, that's probably. I'm not sure if you asked me if that was the reason why I done owner builder, but that was definitely one of them. Like the reactions that you get, even talking about Passive House from standard builders, it's a bit of a worry. So I'm not going to hide it. Like for certain things in my life, I am a control freak. And when I'm spending a couple $100,000 or more than that, I want to be in control of it. That's my money. I'm busting my ass for that money. So I don't want, some apprentice or some trader that hates his job trying to work on my airtightness, because he's not going to do it as good as I am. Or when he's putting up my frames, like he might not get them as plumb. He might, but he might not. Whereas if I do it, they're plumb. I don't move on to the next job until it's perfect. Which that's probably one of the things my dad hates about working with me. He's just like, he's very old European kind of, it's good, it's okay. And I'm like, nah, we got to get it to the mill. So yeah, just that was a bit of an incentive to take on the build myself. Obviously money as well. You do save a lot of money as an owner builder. That's kind of, without, it's pretty obvious that that's going to happen. You're not paying the labor component of it, and you're also not paying like a builder's margin. So it is cheaper, but it is a lot of it's a lot of time of your life that is just it's gone, because I enjoy it. But for someone that doesn't enjoy building and designing and doing all this nerdy stuff, it's just your life gone. Like, kids growing up and you're like, oh, I'm at the house. It's really tricky sometimes. So that's probably one of the downfalls of it. It's always good to save money, but it does come at a cost.
Well, thanks for sharing that, because it's probably one of the things that I feel gets a little skipped over when it comes to owner building, is like what it actually is like in the trenches. How does that impact your family time? If you're a small business owner, does it also impact that as well? So it's nice to have an honest account sometimes.
Yeah, it does. It's 2 years of my life plus the year of designing. The designing time, I kind of just done that during nighttime. So I'd work during the day, put the kids to bed, hang out, and then, my wife would go to bed, and I'm just like a night owl. So I just stayed up till 1 a.m. just designing this house. So that wasn't too bad. But you have to understand, if you're doing owner builder and you're doing it like me, whereas you're doing everything. Like everything in that house, my hands have put there. All the concrete, I dug the footings. I've done everything. If you're doing it like me, there's not much room for much else. And you have to remember as well that if you're not there, it's not getting built. You can own a build where you can be you can take a step back and just do project manager, and then engage a carpenter, engage your trades. I don't touch any plumbing, for instance. So I won't do any plumbing. I won't do any electrical. I didn't do any of the termite stuff like that. So things that I'm not allowed to do, or I shouldn't be doing, I don't. But pretty much everything else, it all takes time. And moving into the build phase, and all of my clients, like they kind of know this. So I had to express it to them when we're onboarding, but they all know I'm building my home. I'll be there from about, it's usually about 8 or 9 o'clock till about 5. So I'll do some light work in the morning. I'll wake up as early as possible, light work in the morning on the computer, and then come home 5, 6 o'clock, pretty shattered, not gonna lie. Hang out with the kids, dinner, bath, bed, sort all that stuff out with the wife, and then it's on the computer, like just working. So I'll do my 6 or 7 hours at night, and it's been pretty tricky, man. Year and a half, it's been pretty tricky.
Well, I mean, you're on the finishing line side of things now. I'd like to say, like
I'd like to think,
halfway.
I'd like to think I am. I suppose once the it's amazing what goes behind the walls in a passive house. Like it is remarkable how much, like, it's funny because in a conventional build, once the plaster goes on, it's like no one cares anymore. Like it just all disappears. Like if the insulation is not installed correctly, no one's ever going to see it again. That person, if you look at the national average, 7.5 years, they're going to move out.
Yeah.
That house will probably get renovated in about 10 to 15. So all that stuff will never get seen again. Whereas when you're doing an owner build, I see it every day. So I've only got tradies there that like I trust. So the sparkly, the plumber, they're all open to the idea. And there's no like, I know I can just put the plasterboard on and I'll never see it again. I'll never see the insulation, Intello, nothing. I probably hope I never have to take the plasterboard off, but I don't think I'll ever see it again. But I'm the type of bloke that's like I try to cut a corner and the next day I'm there fixing it because I can't leave it. Do you know what I mean? Same as with my drafting. Like there's just certain things that I can't like let slide.
I think that's understandable too. It's almost like Passive House was made for your personality.
yeah. Obsessive compulsive. I think it's like,
so you touched on Intello as well there. I just wanted to ask if you could just talk about that and being a vapor barrier on the inside of the wall and the importance of that.
Yeah, so we basically we want to kind of seal up our homes. I'd say as much as possible. Like there's a lot of people, like when I first started talking about Passive House and I was talking to like the builder that I used to work for when I was like a little bit on the tools here and there. And even some other guys are like, what do you mean? Like that's going to be all like moldy and stale air and this and that. And then you have to explain like, oh no, there's a HRV, blah, blah, blah. So the idea and the pushback behind sealing up your home is I think by 2023, everyone's kind of starting to come around that we have to get these air changes down. For those of you that aren't aware, air changes is how we measure the home, how much it leaks. Well, I don't know what the technical term is for that. The leakability. I don't know.
Well, essentially it is, isn't it? So we're trying to determine a way of measuring how airtight the home is.
Yeah, how it retains that air inside the building. Exactly.
So pressurized or depressurized, and it gives us a full result of how many times the volume of that home is exchanging.
Yeah, exactly. So we'll have your standard home. You probably know more than me, but I think it's floating at about 8 to 15 air changes per hour. I think more in like those really old homes.
Yeah, we've only got one study that was carried out by the CSIRO by Michael Ambrose and team there. So it's pretty limited data collection, but I think the average is around 15 air changes an hour for the country. And that number was brought down due to Tasmania because they kind of worked out down there in that colder climate that if we get rid of all the drafts and get rid of all the leaks, it's actually more comfortable in a home.
Yeah, I would probably, if I was a betting man, I'd probably say it's more around 20 plus. I think there might be some builders out there that are accidentally hitting some pretty good air tightness, but I don't think I don't think there'd be much below 10 in my opinion. But getting back to the air changes per hour, so the volume of air inside your building, it comes and goes through your PowerPoint holes, through like cracks, through if you've got an old home and you can see daylight, like all those little holes Underneath your front door, that little 20 mil, 10 mil cut that someone did crooked, that's all just leaking air. And if you're sitting there spending money, let's just say it's like super hot outside, right? And you've spent all this money air conditioning your house, and it's tolerable inside. Your air conditioner is just constantly fighting this uphill battle because all that air that it just conditioned is just running outside all those holes, and it's being replaced with warm air. Vice versa in winter, all this cold air is coming in and your air conditioner is just trying to keep the place warm. But every hour, the air changes 15 times on a windy day. And that costs you money. If you want to save money, while you're building your home, you just build it more airtight. And you've done it really good. Like you're using plasterboard, which a lot of people should be able to get around or get their head around that. It's not too challenging. I don't know much about it myself. So I did use Intello, like you mentioned. That's basically we've got a wrap on the outside, just to simplify it. Wrap on the outside, wrap on the inside. The wrap on the outside is, we're trying to keep our water out while letting it pass through. And we're also trying, on the inside one, we're trying to keep the air inside while allowing moisture to escape. But essentially what that does is it brings our air tightness below 0.6. So again, the standard home, let's just say that's 15. This is 0.6, so it's not even 1, which means that the heating and cooling energy that I put into my home, regardless of season, it remains in the building. And I think the HRV runs at like a 3 air changes per hour. Is that right? Is that like the general rule of thumb?
I couldn't tell you if I totaled up all the flow rates to the volume of the home. I could probably give you a better answer, but
I've heard that. I've heard that before. I think a HRV is typically around. Don't quote me on it. There's probably some HRV guy screaming at his screen.
Joel,
right now.
please.
Yeah, Mr. Fanta. So that obviously does have some type of, but that's like the HRV is like a controlled air change. We're in control of that. The whole thing of Passive House is to be in control of everything. We're in control of the shading that comes in. We're in control of the moisture going out. It's not leaving things up to chance. And a lot of people confuse passive solar design with Passive House. There's borrowed elements of that in Passive House, but like you could build a Passive House anywhere in the world. We're not relying on like opening windows for natural ventilation because that's what our ventilation systems are for. We're eliminating the variables and making it we're making it measured and controlled, so you get a repeated outcome all the time. It's if you do like a solar passive, its building orientation is very important, and the solar passive guys are like super big on that. I'm not picking teams or anything. Like I orientate my buildings too, but in the grand scheme of things, like when you look at blocks that are getting cut up now, the developer isn't sitting there cutting up blocks for solar passive design. Like he's just saying, I've got 100 acres. I want to make some money, and I'm going to cut up these blocks and make them 450 square meters each. I don't care if they're facing south, north. He doesn't care. He's just there to make money. So these days, the typical block, 450, 500 square meters facing whatever way, Passive House works because you can dump your house on there and then you just use building physics, mathematics, the PHPP to balance it out. And that's what Passive House does. You balance it out to a point where you hit the standard.
Well, I think they work both. They work hand in hand. Passive solar design and Passive House complement each other. And it's what we're all looking for is control too, whether we want to acknowledge it or maybe we haven't considered it or given it thought. But when I get home and it's hot inside the house, I want to control the temperature by putting my air conditioner on.
Yeah.
When I go to sleep at night, I don't want it to be 45 degrees, and vice versa, depending on the climate. When it's really cold in winter, I want to come home and make sure my house is warm and comfortable. So I'm looking for control. So this just provides that response or answer to that.
Like you said it as well. Like when you come home, the first thing you do is, most people put on the air conditioner because they want to be in charge of the temperature inside. The other person on the spectrum will open up their windows and be like, even if they got air conditioning, maybe they want that natural flow. They'll open up the front door, open up the back door, and get a good breeze. But that breeze, it brings in everything. It's not just cooling or heating or whatever. It brings in everything: bushfire smoke, pollen, allergies. It brings in everything with it. So that's another good thing about Passive House. Like, I get really bad hay fever. I'm dosed up on Telfast right now, but when that wears off, it's like within a matter of minutes, my nose is running like a tap. So springtime kind of sucks, and I can eliminate that because all the air inside my home is running through my HRV, and it's all filtered. That's gold. Imagine like the feeling. Like, this is one of the reasons why, again, we've done it. Just being at home. The whole purpose of building a house, if you've got a family, is to make a nice, safe place for your family to live, right? That's kind of what. Or else, me as a guy, I don't care. I'll just sleep on a mattress on the floor. I don't care. But that's kind of like how I see it. That the whole point of this thing is to provide, and it's going to be a really good feeling knowing that when the kids are sleeping, they got nice, controlled climate air just going in their room. Like it's all just been cycled through their room. It's not like this build-up of carbon dioxide in the room. You wake up, you feel lethargic. Like, there's nice fresh air being pumped into your room constantly, and that's really important when you're sleeping. Like, a lot of people don't know about that.
Yeah, CO2 build up when you're sleeping, particularly in a bedroom. So let's envision master bed, mum, dad, kids have decided to come in during the night and join. Maybe there's a pet as well. You've got a huge amount of CO2 build up in a very small space, and that is going to interrupt your sleep patterns.
Yeah,
most people will be impacted by it.
And to the people listening, not aware of it, if you had a CO2 meter in your bedroom, and if you sleep with the door the door closed, and you could see the result when you wake up in the morning.
Yeah, well, there's an actionable item. Everyone go get a CO2 sensor and put it in your bedroom and see what it looks
like. I know on your jobs you collect a lot of data, so you can definitely speak to this. Even in your living room, like if you've got like your family in the living room, there'll be a spike. If you have a gas cooker and you're just cooking dinner, there's a spike. Like you're combusting something. Most people's range hoods they're not that great, or they forget to turn them on. You're asphyxiating yourself. That's basically what it is. It's not great.
Yeah. Indoor air quality will be the big topic of discussion for us all moving forward.
Yeah, I think so too, yeah.
I want to circle back now to the wall assemblies. We didn't touch on glazing. So I wouldn't mind if you could just, talk about that, and then maybe shading and how you've dealt with that. Because we have an airtight home, so it's very high risk of overheating occurring.
Yeah, exactly. So the glazing, that was supplied from Logic House. Can't recommend those guys enough. Harley and Jason, they're legends, man. So those windows are, if anyone's been to Europe, they're like the European style tilt turns. They're designed in Germany. I think they manufacture them in Poland or something. Funny thing is, the Logic House windows, you could almost get them landed in Australia to. It's comparable. It's price comparative. I don't think they're overly expensive. I think for what you're getting, it's a bargain in my opinion.
And this is double glazing or triple glazing?
Yeah, double. I did do the maths on the triple, and there's not too much of a price rise when you do go into triple glazing, but there just kind of wasn't a need for it. So the extra money
dependent.
Climate-wise, yeah, exactly. Maybe in like Tasmania or Melbourne, you might want to do it. I'm not sure, but in my area, it's very easy to build a passive house where I am. It was just kind of there was no point for the extra investment. I just put that into wood fiber insulation. So I'm using double glazed timber frame windows. They're just painted black. It's got like an aluminium clad on the outside for a bit of durability, and they look nice, super sleek. People are super impressed when they open them and use them, and you've seen tilt turns before. They're awesome. So we went with the Logic House windows. As in terms of shading, one thing you can do there's another piece of software that complements the PHPP, which is called Design PH. It's basically, for those of you that use SketchUp, it's a plugin that plug in SketchUp, and you model your building into like a nice 3D model. You assign all the walls, the windows, the roof values to that model, and then you can export that data into your PHPP. One thing that Design PH software does is it's basically got like a realistic sun path, which most drafting programs do, but SketchUp is one of them, and it utilizes that by measuring the shading of all the windows or the doors. So that data also gets exported in. So what I did was I actually, because my house is getting built in a new estate, I approached all my neighbours, all but one gave me all their plans. So I managed to get their plans, and I 3D modeled their houses at the correct RLs, or the correct levels where they're going to sit. And I had an accurate representation of the terrain. And then that was in SketchUp, which if any of those buildings casted shade or shadow on my windows and all that was taken into account as well. So it's great if you can do that. And if your designer can do that for you, that is fantastic. Another thing you can do, which I did, was for that neighbor that didn't give me his plans, I actually own a 3D building scanner. So I said to him, all right, no worries, man, not a problem. I went on my vacant block. I stuck my 3D scanner in the middle, and I just done a big 360-degree sweep, which gave me like a point cloud that I could put into Design PH and model his building based on that. So even if it isn't a new estate, you still can. Like you can capture trees, stuff like that. And there are people that do building scans and point cloud scans throughout the country, so they're not that hard to get. So I used that. So that helped kind of determine the amount of shading that I had. And also on my western side, I've got a split level block of land, so it kind of put my bedrooms on the western side, which I, at all costs, I really try to avoid as you would. You don't want a hot bedroom, but when you pair up the ventilated cavity, the 25 millimeter external ventilated cavity, the 40 millimeter board, and the 90 millimeter bat, that gives you like over 4,000 joules of energy per square meter of heat absorption. So basically, in 1 square meter, I think the lag time from the product data of the wood fiber thing, it says it's like a 4 to 6 hour lag time to get through one layer. So when you pair those up, yeah, it's crazy. It's mental. So for those of you that can't imagine it, just think of like 1 square meter of insulation or of that wall. It will take 6 to 8 hours for me to even feel any type of heat. And because it's directly west, I'm only going to get western sun for like, what do you reckon, maybe 2-3 hours? Like by the end of the afternoon, it's gone. So I took that hit, and then I just added some external blinds, which were ordered through Logic House, that I just put on the outside. That's another hot tip. A lot of people think that putting blinds on your inside is like the solution, but once it's past your window, past your glazing, it's in your house. That's it. Anything beyond your glass, that energy is through there. So honeycomb this, curtains that, it doesn't matter. Like it doesn't work as good as external blinds. So any type of like fixed awnings, I've got a couple of fixed awnings, or external blinds, that's where you want to stop it in its tracks before it enters. So I've got a couple of blinds on my home as well, on the western side.
Yeah, because once it's out into the home, that now requires energy to continue that space. So
that's it. It's in there, man. That's why people with skylights are like, oh, it comes with an internal blind and this and that, but it doesn't matter. It's a hole in your roof. I know they look cool, but it's a hole in your roof. It's a wild thing to do. And if there's a client out there that wants to do them, I'll do them. There's no dramas. Like we can detail them correctly and make them pretty durable, but you've always got that risk. And B, there's only a couple that have external blinds, and they're very expensive. So yeah, if you're going to do skylights, you have to spend the money and do it properly.
I call them heat chimneys.
Yeah.
When you put the thermal camera over them, it's like, whoa.
Oh, yeah, I've never done that before. Yeah, that would be, cool. That would be interesting to see. I don't have a thermal camera. I'd love one, but God, that would be so cool to see. Chimneys are a funny thing as well in fireplaces. Like, as a building designer, I'm sure you've had this conversation a million times where someone's like, oh, I just love the romance of a fireplace and this and that, blah, blah. But people have to understand in Australia, like, to have a fireplace in a passive house, you're going to be cooking. That is like 5 minutes. It's going to be hot. It'll almost be unbearable. You'll end up putting it out. So my option for that is, I suppose you can do like an ethanol one. I'm not sure, but just put a fire pit outside, because that's kind of like a nice middle ground. It's cool to have a fire outside. You know what I mean? If you have like an actual fireplace, you'll never air seal it properly. I know there's passive house fireplaces, but even then the overheating would be phenomenal. I'm getting off glazing. I'm all over the place. I'm so sorry.
No, that's a good topic as well. Having a fireplace in a passive house is one of the most frequently asked questions also. So,
oh, man.
And I just want to make sure that listeners understand the reason why we're saying this is that once you go airtight and you've got these higher and thermal insulative envelopes, way less energy to just keep them warm. And so therefore, if you have a huge amount of solar gain and it's coming in through your windows that aren't shaded correctly, it's going to heat that home up very quickly.
Yeah, very quickly.
Because it requires such little energy to do so.
Yeah,
so touching on how detailed you went with your shading and what you did to do that, that's great.
Yeah, I've got a quick little story about like heating and cooling requirements. So one thing that people might run into, and even with like the conventional builder that's maybe trying a passive house, which is, that's cool. I'm all for that. But they also have to speak to their trades, especially the refrigeration mechanics, the guys that install your air conditioning, the ducted, all that kind of stuff. So you have to also understand that. But my particular story was I was trying to convince my air conditioner installer that I only needed like a 5 kilowatt ducted system. I found one. They can make one. I want to use that one. Can we put that in? He thought I was mental. He thought I was absolutely crazy. He goes, nah, like he was this European guy. He's like, nah, bro, you're going to need like 20 kilowatts minimum for this size house. And I'm like, it was like, it was pushing shit uphill. I had to, he just couldn't, he refused to basically put in anything smaller than a 16. And I went through a couple of air conditioner guys until I found one where I'm like, please just take my word for it, bro. I've done the maths on it. And he was like, yeah, that's cool. Like, if you've done this, and he still thinks that it's a bit odd. But again, it goes to that thing of like you have to pick your trades and they have to be kind of open to the idea. Because that first guy, even the second and third that I interviewed, he was like, he thought I was mental. Because typically,
I've had this happen so many times as well. So maybe talk about how you determine that. You're obviously going to circle back to PHPP here. But it's obviously there's a way you can do that.
Yeah, in the PHPP, basically, once you input all your wall build-ups and this and that, it tells you how efficient the building is. It spits out a couple of numbers. And then one of those numbers is your heat demand or your cooling. Is it cooling load? Is that what it's called? Cooling.
Yeah.
Yeah, so your cooling loads and your heat load. So what the building requires input-wise in order to maintain a 20 to 25 degree temperature, for instance. We'll keep it simple. So my home came in at 5 kilowatts. I think I haven't looked at the PHPP in a while. You've seen it more recently than me, but I think it was, I had more heating.
I remember your cooling demands being a lot higher than I would typically see here.
Oh, my cooling, okay, sorry.
Yeah.
My cooling demands were a lot higher. Well, I don't remember one of the two. But I could get away with, maybe 2.5 splitties just throughout the house. To keep it neat, I thought, okay, well, I'll put in a ducted and they can do like a 5 kilowatt because when I put in to the PHPP 5 kilowatts of cooling, the PHPP says, yep, cool, gives me the tick and satisfies. Like that criteria is met, so that's all good. And then that's what you'd kind of tell your air conditioning installer, like, that's kind of roughly what I need. I think it's good to oversize. So I went to a 7.1. And then I felt like I was reverse haggling with my air conditioner installer. We settled on a 10. So okay. I've got a 10 kilowatt system in my home, which the price point between the two was I think it was $300. So there's once you're doing ducted kind of. There's no real like big jumps in price. So I thought, okay, listen, for $300, just chuck it in. I'm not going to have this argument. We got to move forward. So the 10 kilowatts going in, it's all ducted, and there's something else interesting about it. Oh, I've lost it.
No, that's okay. I'm curious as to what you've had to do to facilitate a ducted system, because typically I would see just a standalone wall bulkhead unit for a reverse cycle air conditioning system.
So in my home, as I mentioned, the 300 millimeter I-joists are acting as my rafters, and I opted to put my the roof system. There's a lot of decisions in my roof system to make it that way, and one of those ones was to get the insulation up in between the rafters. That's like, again, in my opinion, that's the best way to do it. You want to have the insulation at the outmost point of the building, if it's possible, which that would kind of leave me with a cavity you could imagine in between my watch got caught. In between the ceiling and the rafters, I've got, a couple of 100 mil on the high point up to a meter. So the good thing about that is, because your insulation is up near your roof sheets, your service cavity, your ceiling service cavity is treated area, like it's nice conditioned air. If you think about a standard home, it's absolutely crazy how people do it. I think it's one of the wildest things ever. But you'll have your outdoor unit on the outside of a typical ducted system, and on the inside, in your roof, that probably gets up to like, I don't know, what do you reckon? Maybe like 55, 60 degrees. Like it gets pretty hot up there. Yeah, it can. It gets hot. You've got an indoor unit. The indoor unit itself, it's not very insulated. It is to a degree, but they're not like, they are designed to run in those areas, but it's not a good idea. You've got air being cooled in that indoor unit, getting pumped out in these 300 mil insulated ducts, and all that ducting, we're talking like, it could be up to like 10, 20 meters of ducting is just running through this 60 degree bloody roof space and then dumping it into your house. Like the beauty of having your insulation up, that becomes your conditioned space. It's kind of like a conditioned attic where you can run it within the conditioned space. So there's a lot less, there's a lot less heat loss. There's a lot less heat getting in. It's kind of having if you could picture in a standard home, your ducting is running inside your house. That's probably underneath the ceiling insulation. So
yeah, no, it makes total sense. And I think the biggest thing to compare that is that you've got very much reduced energy loss, right? Like regardless of cooling or heating. Yeah.
And it's all money. Energy is only getting more expensive. There's anything you can do to regain or put money back in your pocket, it's a win. 100%. Like it's. I don't think the government's going to wake up tomorrow and buy back electricity and start doing it for cheap again. It's just not going to happen.
No, if that does happen,
God.
waking up in a parallel universe.
I'd love that. That'd be fantastic.
Thank you for listening to the Outlier podcast. You can find helpful links and contact information regarding this episode in our show notes and on our website, outlierstudio.com.au/podcast. If you like our show, please leave a review and make sure you subscribe to never miss a new episode. If you have further questions for us or would want to share some additional feedback, please feel free to DM us on Instagram or Facebook. Until next time on the Outlier podcast.